So while the condition is true, the same thing that we did for conditioning in if else, the same operation that we did. And while this is true, then it will execute the statement inside. Okay? And this position, the statement, this is the condition. And you need to remember to initialize the variables for the condition. In most, I think if you are using C++, you can declare inside, but if you are using C, you need to declare and initialize the variables outside the condition, outside this function, and then printf and then I++. Usually, increment or decrement is the last part. Because why? Because you don't want the increment to mess up with your statement. So it is better usually we do the increment at the end of the at the end of the statements, at the end of every statements. So for example, in this case, this one is to generate n natural numbers. So and then you scan the number of n, read and store the number. Or maybe you can use, you can also use right here, you can write right here, define n equals to something. And that will be considered a constant. And then you printf. All right, so for example, like this, include your library. In this case, because why I have std library, standard library, because I need to call this function system pause. So if you are using, if you are installing the DEX C++, you need to use this if you want to show the output, and then I need to have the standard library. In some cases it is okay, some cases it's not. But if something happened, if something, if an error happened, maybe because you didn't put the standard library, you didn't include the standard library. All right. So as you can see in this case, while it's just a number. So meaning that this will be false when I equals to 0. It doesn't matter what value of, let's say I is 2, I is 4, any numbers other than 0 is true. Okay, so I repeat that again. Any numbers other than 0 is true. Only 0 is considered as false. Okay, so I think I already show you this last time. So because why? Because this one is I minus minus, that's post decrement. We already talked about this last time. I think we also talked about this last time. So this is to find the x to the power of n. Let's say if you enter n equals to 2, so x to the power of 2, and then how many counting it will be. All right. Any question on while loop? Have you? Okay. I think. Okay, it's okay. Okay. Do while loop. So this, what's the difference between while loop and do while loop? So you can see that the structure is different. You execute first and then check the condition. So meaning that you do your action and then after that check your condition. This is like you are doing an experiment. Do first and then see if the condition is met. Doing first and then test the condition. So let's see, in this case, if you see the flow chart, this is reverse. In while loops, the text expression is on this side, on the upper side, and then the statement is below. But in the do while loop, the statement, the action is first, and then after that, the condition after later. So, and then if it's true, then it will go back to this one. Why we do something like this? Because sometimes we need to test the step at least once before checking the condition. So we need to see if, for example, maybe our answer is true or maybe our answer is what's supposed to be, it was supposed to be. So for example, I want to see the output. I want to see my output first, and then after that, if my output is okay, then I will continue. If my output is not okay, for example, if the body of the loop, my calculation is not good, maybe my calculation will have a minus, square root of minus. So maybe the test condition say something like my square root is minus something. So my calculation need to be rechecked. Okay, so sometimes it's good to do this because you want to see what's happened after that, after you do something. All right, for example, in running a maze, why this is in running a maze? For example, in a maze, I don't have my open speaker. Yeah, I don't have my, hold on. This one doesn't have sketch. This is only laser pointer. So if you are running a maze, for example, you go first, and then when you met a wall or some obstruction, then you go back and then go to another way. So that's like a running a maze. You run first, and then if you see something that you cannot run, then you go back, something like that. So example number 2, inflating a tire, same thing. You put on the air first. You put on the air, and then when the pressure inside the tire is, let's say, for example, receive a maximum pressure, then it will give you a beeping sound. So this is so if you apply to while loop, if you apply this the air pressure machine, then it will not happen, because it will happen first, but for example, it will be a bad situation when your tire is in good position, is in good pressure, but when you put in more air, and then it will burst, something like that. So you do first, and then the moral of the story is, in do while loop, you do first, and then check the condition. Okay, you can see that the format is almost the same, right? The only thing that is different is that do while we have do above, and then while is at the end. And notice that in while loops, you don't have to put this semicolon. However, in do while, you need to put the semicolon at the end of this function. So if you remember, if you recall, we don't have to put the semicolon right here, but the format is the same. You see that the increment is at the end of the statement. Same thing for this one. You see example number 2 in this one. So you initialize. I didn't put the initial. I didn't declare this one, but it's above right here. So I equals to 1, sum equals to 0. Always initialize and declare your variables before doing something. Right, and then sum equals to sum plus 4, I equals to I plus 2. So in this case, it just to see the increment between these two, and then you need to, it will only print out once, because this printf is outside your do while loops. So as you can see that which one is both need to be false. So this one should be false, and then this one should be false, so that the condition is false, both conditions. So you need to have a sum reach 25, and then I reach 10, so that both conditions are false. Unless you put, so it will be really a long iteration, but if you want to make it stopping at fast rate, just use ampersand, double ampersand right here, and the logic n, and then it will stop For example, it will stop which one? It will stop whenever one of them is false. So you can see that you can have, this is called composite condition. Okay, why composite condition? Because it consists of several conditions. Compared to this one has only one condition, which is count less than 4. However, in this case, this is like 1, 2, 3. 3 kind of relation and then logic operation. So this is logic. But you don't have to worry about this because you can always look at the comparison and then try to run it in your C programming. All right, so what's the difference between these two? Both works for looping, no problem. You can do it for looping. And then you can be used either way with minor adjustment, like I told you just now. For example, the while is above, the function while is above, and then for do while, the function while is at the end, outside the curly braces, and then you need to put the semicolon. In do while, expression is firstly executed. So it should be statement. Statement is firstly executed, and then the condition is checked after that. So in while, you check condition first and then execute if condition is true. This means that, for example, if you put the same condition for do while and then for while, meaning that do while at least will be once executed for the same condition if you do this do while and while. Okay, let me show you an example. Okay, I hope that you can see this thing. And can you see clearly, or is it really small? Okay. This one. Nampak ke?
Nampak, Doktor.
Nampak, eh? All right. So let's see an example for while. Let's bring one example. I want to disable this one. Okay, while let's say I need to declare my variables and then initialize it. Okay, while let's say integer I, let's say start from 0. Let's use a simple one, while I, then the value f, print f, the value of I equals to and then I print out I, and then my increment is I plus plus. Okay, so you can see that I start from 0 and then I just use while I. Okay, let's run this. Okay, you can see at the bottom, maximize, you can see that there's no output. It's just press enter to exit console. Okay, now let's change this for do while. Okay, so this is while, and let's do this for do while. Just want to copy this one. Okay, and then while. Okay, I want to disable this one. Okay, because I just want to use my do while. Let's see the output. Okay, so in this case, did I do anything bad right here? Ah, I see. Okay, so if you want to stop this, you just use Control C. I equals to 0. Oh yes, because I use I++ right here. So it means that I plus 1 is, it will be always true because 1 is, the sun will be I equals to 1. Okay. And then that's why. Okay, I just use like that. Okay, you can see that the value of I equals to 0. So it will only execute once. Why? Because this one is, one is 0. What I did before, because I copy paste this one, so you can see that if I put I++, then at this condition, it will increase by 1 every time, and then this one will always be true because 1 and above 0 is true. So you need to be careful with that. Okay, so because the condition is false, then it will only execute once. So if you compare this, maybe I can say output while. You see that output for do while. All right. Okay. So that's okay. So you can see that only the do while has the output, but the while there's no output for it. Okay, but let's say what happened if let's say yes, I start I integer I from 1, and then my condition is the same. You see that the condition is the same, but my starting point is my starting point is start from 1. Just now it start from 0, and now let's use this one. Is it going to make any difference? So I cannot use this condition while I, because you can see that this one will be an indefinite loop. Indefinite, it will be a finite loop, so it doesn't stop. So that's like a logic error. Okay, so let's see. Let's say I is less than, let's choose 5. So equals to 5 because I want it to stop at 5. Okay. So now let's try to run it. Maybe I can separate this first because you don't see the difference. Okay, let's see this one. Okay. Hold on, you can see this. Okay, now let's try that again. Okay, so you can see that output for while is 1, 2, 3, 4, 5 because you expect that because I start from 1, and then after that it will increase by 1 and then stop at 5. Okay, now I want to do this again, another one again for while loops, and then I want to put my I++ above. Okay, so I++ above, meaning that you are going to start I from 2. Let's see if my expectation is true. So you can see that I start from above, start from 2, and then it will end up with the last point will be 6. Okay, because why? Because you start from 2 plus 1, and then after 5, it will check, and then 6, it will add first, and then I is true. I don't have, I want to show you something, but let me see. Why is it the output is until 6? Okay, let's see this one. Okay. Okay, so this one, for example, why is it I start from 2 and then it will end up at 6? It doesn't end up at 5. Okay, let's see this one. Let's try. Okay, let me see this one. So integer I start from, and then this one is I plus plus. No, sorry, I is less than 5. And then we have I plus plus. And then we have printf. Okay, now I start from 1. Okay, and then I is less than 5, yes. And then I plus plus is 2. Print number 2. Okay, and then it will check, and then after that I plus plus is 2. Okay, this is okay, less than 5. So it will I plus plus 2 plus 1 is 3. The output is 3. And then it go back right here, 3. Less than 5, yes. And then I plus plus is 4. Then the output is 4. So why am I doing this? So if you need to do the schedule right here according to this one, to the statement right here. You can see that I start from, I think it's better to share my screen. Okay, so I start from I and then check my condition right here, check my condition, and then I plus plus. After I plus plus, I use my printf. So the same thing right here, my initial condition is my condition, and then increment, and then statement for print. Okay, now let's go back to right here. So increase by 1. So this is true. I plus plus is 5, and my output is 5. Okay, now they say after that increase by 1, take this one. I less than 5, so this is true. And then I plus plus is 6. And then I have 6. So that's why my output is 2, 3, 4, 5, and 6. So why? Because if you go back to this one, 6, if you just continue from this one, 6 is not, is false, so it will not print out. So it will only be 2, 3, 4, 5, and 6. Okay, any question on this? Any question? No question?
No question, Doctor.
Okay, can you understand this? The process?
Yes.
Yes, all right.
Yes, Doctor.
All right, so let's try to, let's use this one. If we put the printf first, and then after that, we increase. Why? Because you need to understand how this C++ works, because it will save you a lot of time. Why? Because when you do your programming, you need to plan your work first, and then in order to master your planning, you need to understand how this works. All right, now if I put my printf, And then after printf, I use my increment. Okay, let's erase this one. Okay. Now I start the same thing. I from 1. 1 is less than 5. Okay, so it will print out 1. And then I plus plus, it is increased by 1. So it becomes 2. So it will go back to the next line, to the next step, which is I start from 2. 2 is less than 5, yes, and then it will print out 2. Okay, after it print out 2, it will increase by 1. 2 plus 1 is 3, and then 3 right here. 3 is less than 5, yes, so it will print out 3. 3 increased by 1 is 4, and then it will be 4 right here. So 4 less than 5, yes, it will print out 4, and then 5. It go back to the initial value 5, yes, less than 5 is less than or equals to 5, so it will print out 5. Okay, and then it will increase by 1, 6, and then 6. The condition is false, so no print out. Okay, so I think you can understand this. The difference between how do you, if you put this one first versus if you put it later after that. Okay, now this is for while loop. For your information, I'm writing using my mouse. Okay, now let's use the do while. Okay. Okay, let's see this one. Now I want to disable my while loops. Okay. Okay, let's see, is there any syntax error? I don't think so. So this one is just spelling a typo. So I start I from 1, and then I plus plus at the end of my this one, and then while I is less than 5. So let's see the output. So the output is the same thing. You can see that after this one, if you put this the I plus plus, the increment after the printf, the output is the same for do while. Just now you can see that there are difference when the first step is false. If the first step, the condition is false, then you can see that the do while has an output, but the while loop doesn't have an output because the condition is firstly false in the first step. Okay, now if I change my I plus plus at the front, okay, and then I use I plus plus right here. So the same thing, you can see that the same thing happened. So let's try to evaluate this one. Okay, for do while, let's use the regular one. So do while start I, and then I do first, meaning I printf first, and then I have my increment I plus plus, and then I have my condition after I plus plus. My condition is I is less or equals to 5. Okay, so I start from 1, okay, and then it will print out 1. My output is 2, and the increment is 2, so 2 is less than 5, yes. And then my initial condition is 2, so it will print out 2, and then I plus plus is 3, so the condition is 3 is true, and then becomes 3, it will print out 3, and then I plus plus is 4. So the condition is still true, and then becomes 4. It will print out 4. I plus plus is 5. So it will print out 5. And then the last one is for I is 5. And then it will print out 5. I plus plus is 6. But 6 is false. So you can see that look at the printing part. It will print out 1, 2, 3, 4, 5. Same thing that we do, same thing for Y. But after this, it will not print out because the condition right here is false. You can see that the difference between this one. Okay, now let's look at if we put I plus plus at the front before, and then after that we use the print. Okay, it's quite slow. Okay. All right. So my print F, no, I plus plus first, and then my print F. All right. Now let's look at the output. I start same thing. I start from 1. I plus plus is 2, and then it will print out 2. Yes, 2 is less than 5. Yes. So the last value for I is 2. 2 increased by 1 is 3. So therefore it will print out 3. Okay, so the last value for I is 3. So this is less than 5. Yes. And then go back again. It will increase by 1. Then it will print 4. The last value for I is 4. So 4 is less than 5. Yes. And then this one is 4. I plus plus is 5. It will print out 5. Okay, the last value for I is 5. Yes, and then it will print out 5. 5 plus 1 is, the last value for I is 5. And then 6, it will print out 6. Okay, then it will check the condition 6. No, this is false. Okay, so the printing will be the same thing, 2, 3, 4, 5, and 6. Okay, even though the last one is 6, you can see that it will print first, it will do the action first, and then it will check the condition. So you can see that the do while loops and then the while loops is almost the same, except that it's the same, except that what? Except when your first condition is false. Okay, when your test condition is false, in the first place, in the first step, then the do while loop has an advantage over while loops. So that's the advantage of using while loops. Do while loop, excuse me. All right, now, any question on that? Okay, so no question. Let's move on to the next one. Let's move on to the next while loop, the looping, which is for. And for is quite, is mostly used in terms of array and in terms of many applications. And then this is also the for loops is also the most simple in terms of its syntax. For example, you can see that in this where is my this one, you can see that the body of the loop, not the body of the loop, the the condition, the test condition, and then the increment, it should be the increment right here. And then the increment is in separate line. So they are separate. But if you do the for loops, you can see that the initial value, test condition, and increment is on the same line. So everything is on the same line. So compared to the first two, we have initialization above, test condition, the next step, and then the increment at the end. And if you were talking about do while loops, your initialization start from also from above, and then your statement, increment, and then your test condition. So you can see that this one is simple, the most simple one, because the only thing that to make difference between these three is the semicolon. So you need to put semicolon in between them. And then you need to know the position. So you need to remember that the first part is your initial value, and then your test condition, and then your increment. You cannot like switch this one and then to this one. It won't, it might have an error if you do something like that, if you change the position. Okay, for example, this is how we do. For example, my initial value is, you need to remember that you need to declare your variable outside this one. Always do that. You declare that integer I, or maybe a float double I, something like that, and then you put the value inside this parenthesis. So I start from 0. So your initial value I start from 0. I is less than 3, your test condition, and then increase by 1. And then you can see that if I is less than 3, meaning that the counting will start from 0, 1, and 2. 0, 1, and 2. The total steps is 3, but the index is start from 0, 1, and then 2, until 2 only. Okay, the next one, the next example, for t equals to t initial, t less than t max, and then you can see that t plus equals to n times dt. You can also do the operation in increment. So this is increased by n times dt. And you don't have, in this initial condition, initial value, you don't have the data type is not necessarily be integer. You can have the same data type for any numbers. For example, you can have float, you can have double, long double, and so on. And the same thing for the third examples. You start from 10, initial value start from 10, and my test condition is positive. You can see that it stopped until 0, and then my decrement is minus. So it's the same thing, except that how you want to place them. Okay, this is an example. You can see that the difference between while and do while, you don't have to put the curly braces, this so this curly braces right here. If you have is a one statement, same thing for if else. If you have only one statement, you don't have to put your statement inside a curly braces. So you can just leave it like this. So meaning that only the first line will be executed. If you have another second line, and then it will not be considered inside this for loops. So same thing like here. We start from initial value c equals to 0, c is less than 10, and then c plus plus. And you can see that the output, you expect the output to be 0 until 9. Okay, let me see if let's see if my prediction is true. I want to use I am going to use C. So let's use the same statement. Okay, so I start from 0. Just initialize my value. And I don't want this while and do while. I only want my for loops. Okay, so just declare my variables. And then I use for I equals to 0. No, where is I? I equals to 0. So my initial value, this one, I equals to 0, and then I is less than 10. I is increased by 1. And then my output is printf, this one. For loops. Okay, now let's see. Okay, so you can see that the output right here at the below. So what I said, so my expectation value is true. So I start from 0 until and increase by 1 until 9, because my condition is less than, it's not equal, less or equal. So if I put I is less or equal, less and equal, so you can see that my output will be until 10. So this is one of the error when you make, if, for example, you need to be careful, and this is called off by 1 error, usually happen in loops, in for loops or any kind of loops, because you forgot to put this one. And you also need to be careful if you start from 0, you might not want to start from 0, you just want the natural number, and not natural number, you just want the counting number, which is 1, 2, 3, 4, 5, and so on. So you don't want 0 sometimes. So just be careful with your initial value and your test condition. And also be careful with this increment or decrement. Okay, so let's see this one. This is also the same thing. You have the composite test condition. If you remember from last example in while loops, this one is n, and not n. This one is or. Okay, or some. So in this case, this one is depends on which value that it will reach 0 first. So you can see that I should be integer right here, integer I equals integer I, and then I forms 1, and then my condition, and plus plus I. Okay, and I also want to you to see the difference. In this case, this is plus plus I, and just now I did I plus plus. So is it going to make any difference? Okay, so I plus plus just now. Okay, you can see that I do I plus plus, and is it going to make any difference if I put plus plus I? Okay, so the same thing. I just change I less than 10, so it doesn't until 10. So stop until 9. It will stop at 9, and then you can see that there's no difference if you put plus plus I or I plus plus for loops. Okay, so it doesn't make any difference. Because why? Because this one is on the same level. So if you do post increment or pre-increment, it doesn't make any difference. Same thing for here, it doesn't make any difference if you put I plus plus or plus plus I. All right. Any questions so far? Any questions so far? No? Hello? Guys, are you there?
Yes, doctor.
No question.
No question. All right. Okay. So if you have no question, then I'm not going to start until 9. So we have 1 more minutes. Okay. I don't want to see the output. I just hope that you can understand from this what we did just now. So this is just to show you that this test condition can also have the composite statement. In this case, composite, the same thing. We have 1, 2, and 3 different kind of relation and logic operation. All right, now let's try to compare all kind of tree loops. Okay, now I want to change the loop to for and do while. Change this loop. Okay, and with that, let me share this Jamboard, and then I hope that okay. Now I've shared my Jamboard. Now, if you please to click on that so that we can share your answer. For example, okay, now change the loop to for and do while. Okay, let's say this x equals to 0, and then while x is less than 10. And then print f. So the question is changed to for loops and do while. Okay, and we are going to take a 10-minute breaks, and then we'll continue after the break. If you can change this into for loops and do while loops. Okay, anyone want to try? So just remember the format or the syntax for loops and then the do while loops. Or maybe any of you have tried to run the output. Let's discuss about the output first. Okay, so from this, what is your output should be? It should be from 0 to 10, right? Because it starts from 0 until 10 and increase by 1. Okay, I saw somebody want to try. Maybe you can try. Okay. Let's use for loops first. Do while after that. Let's use for loops. Hmm. Okay, for loops, integer x for x. This is quite small. Let me increase the, yeah, thank you for increasing the size. Okay, so you can see that x is 0, x initial value is 0, and be careful with the capital F, because I think that's the AutoCAD. X comma equals to 10. Okay. So is this okay? This one? Anybody wants to comment on this? X equals to 10. Somebody want to correct it? Or maybe are you satisfied with the result? Yes, now it is okay. Okay. So be careful with the syntax error. Be careful with your timing. And this one is also, this one should be what? Should be small case f. And then, for example, print f, because you have only single statement. For single statement, just so you don't have to put the curly braces in this case. Okay, now this is okay. How about the do while loops? One more thing. One more thing. This one. Okay, I forgot to see that. I will see that. Okay, be careful with that because we don't have the semicolon. Okay, let's see. Integer x equals to 0. Do printf. All right, and then x plus plus y. Okay, and then that another one is x equals to 0. Printf. Okay, this one, be careful with this one. Be careful with what? Syntax error right here. You need to put the semicolon right here, and then this is also a big D. It should be a small D, and then printf should be small p. And then while loops, you do while loops. Remember that at the end, because this is like a sentence, at the end of this, you need to put the semicolon. So, and then remember that this one for loops, okay, for loops, you can see that there is no semicolon right here. Okay, there's no semicolon right here. And the same thing for while loops. Okay, this is the do while. Okay, you can see that this one, while loop doesn't have the semicolon. Okay, compared to the do while you have semicolon. Because why? Remember that this looks like a sentence, the whole thing, and then every sentence in C you need to end with semicolon. Okay, now I think most of you are doing okay, because I can see that many of you are able to answer this one. Minus x. Kenapa ada minus x kat sini? Why do you put minus x right here? Okay, boleh tak siapa yang jawab ni? Siapa yang buat yang bawah ni? This one? This one? Can anybody answer why you put minus x right here?
Doctor, can you hear?
Yeah.
It's me. I think the for loop will auto have x plus plus after the loop.
X plus plus after the loops. I don't quite get your explanation. Yeah, maybe you can write if there's some problem with your microphone. Maybe you can write in the chat box. So for those who have a problem in their audio can read your explanation. Yeah, my question is about this one. Why do you have minus x right here? Yeah. Do you have problem with your connection, or you have problem with your microphone? Because I cannot understand, or maybe I can't. For the for loop, we have xx after last. We'll have x plus plus after the last. Oh no. So you see the difference between for loops, then yes, x become 11. The last one is 11. No, 10. The last one is 10 because, and then the last value of x is 10, and then it will increase, and then increase by 11, increase by 1, so it becomes 11. Yes, but my question is, why did you put minus x? I just want to see the logic behind your statement right here. Okay, let me try to look at this again. Okay, you see this one, the online C compiler. Let's delete everything but the for loops. Okay, and you can see that there's only one statement right here. So I put my initial value, integer x. Okay, integer x, and then x equals to 0. X is less or equal to 10. And then I have x plus plus. Okay, now this is my output, x. Okay, this is my original, I got this, this is answer from this person, okay, without the x minus x. Okay, now let's try to run this one. Okay, now we can see that the output start from 0 until 10 because my initial value is 0 and then my last value is 10, my last value in this loop. Okay, now if I put, if according to your statement, I have minus x right here. Okay, can anybody see this? Can anybody see this? I put minus x right here. And yes, so let's try to run this. Okay, now, so there's nothing problem with that. Why? Because my only output is the printf in the first printf for loops. All right, and minus x doesn't has anything to do with my for loops. Because why? Because this is outside my loops. Remember that if I have one statement only, I can put just like that. But let's say I want to include, let's say, no, let's see, it's okay. It's not a true or false. It's not a wrong or right. But I want to see the logic behind this one. It's okay, we can try. Okay, now let's see, printf. And then I want to put minus x inside my loops. Okay, now that looks like a counter increment, right? Because you expect that x doesn't change. X is always less than 10 because you plus, after that you minus, and then it will go an infinite loop. As you can see that x is always 0. Okay, so infinite loops. So you press Ctrl C to stop it. All right, now you can see the difference between when you put the curly braces versus when you didn't put the curly braces. All right. Okay. Did you get? Can you find? Did you understand this? Did you get what I'm trying to say right here?
Yes, doctor.
Okay. Good. All right. Now we did this. So you don't have to put another minus right here because it will be a counter the increment or decrement. And you can please also be careful with this one. So this one is what? This one is like what kind of error is this? So this one is like logic error. So why logic error? Because infinite loop is not supposed to happen in calculation. When something happen, when infinite loops happen, then you made some mistake, usually in the case of the test condition. Your test condition is always true, and then it will go on infinite time. And usually in that case. And what happens if there's no output? For example, if I want to use for loops, and you can see there's no output at all. Okay, now the same thing, you need to test, you need to see your test condition, because the test condition will determine whether or not there will be an output. Because as long as the test condition is false, then there's no output, because the condition is false. The requirement is not met. Same thing. Okay, you can also see that this is the same thing that when you do password, when you try to log in, and then you put in the wrong password, and then the message, when the first time you type in your wrong password, and then it will display you have 4 more attempts. Because why? Because the character of your password, they try to match the keyboard input and then the file that's stored in their program. Okay, so they want to match, and then when it's false, then it will count. It will be a countdown. So you have 5 trials, and then when after you fails to fulfill your correct password, and then it will block your account and so on. So you have to call the customer service and so on to open your account back. Okay, so this is the same thing. You are doing looping, and in some cases, they don't care how many attempts that you do. It will display the same thing. So it's the same thing. So it will display the same password and then your username and so on until you get it correctly. So in some cases, it doesn't care, but the moral of the story is that it will display the same thing, asking you your username and password. It doesn't stop at only once. Okay, so that's the one example of using the loops. Same thing, for example, if you have a alarm system, it will go on until something happen, or maybe, for example, smoke system, the buzzer is going to go on until you put out the fire and so on. Okay, so that's the usage. Another example is that when you use you want to plot a polynomial equation. For example, the simplest linear function is y equals to mx plus c. Okay, that one is also using loops. So x is increased, let's say x is increased by 0.1, 0.2, 0.3, and so on. And then when you do the computation, you get the value of y. Maybe you still don't understand. Then I will show you later on the example of it. Okay. Okay, I think this is an easy one. Okay, now let's do some exercise on this. Okay, now let's do this one. Okay, maybe the Jamboard is quite hard. Maybe we can do in the chat box. So maybe you can try. Let's try this one. Change it to while and do while. You can type in the chat. You don't have to put in the Jamboard. Okay, tak ada siapa nak try ke? Try ni, while and do while. Kita ada siapa nak try? Okay, kalau tak ada nak try, saya skip saja. Saya tak nak selesaikan. Awak fikirlah sendiri. Alright, I want to go on to the nested loop. Okay, you can see the nested loop. This is the same thing for that we did in the if-else, nested if-else. Okay, so usually the purpose of this nested loop is to access multi-dimensional array. Okay, so for example, if my what is multi-dimensional array? Multi-dimensional array usually, for example, 2-dimensional, 3-dimensional, and so on, or 4 and so on. Okay, an easy example is like a table, because table is multi-dimensional array. You have your column and you have your rows. So one is for the column and one is for rows. Same thing for this one. The outer loop usually is for the rows, and then the inner loop is usually for column. Okay, so the same thing apply, which means that first thing is you need to make sure that my test condition is true in order for the inner loop to go on. Okay, unless the outer loop is false, then the inner loop will not be executed. Okay, the same syntax, as long as you are using a different variables. Right here you can see that this one is I and the next one is J. Okay, you can also understand this in terms of matrix entry, because why? Because matrix entry for the first column and the first row is I11. Second column, first row is I21. No, I12, the other way around. I12, I13 until I1n. So this is the same thing if you are using it to apply in matrix. So this is useful in terms of matrix computation. Example is determinant, to find the determinant, to find the matrix multiplication, matrix inverse, matrix division, and also any other kind of matrix, elementary product, elementary, what do you call it? Elementary operation in your linear algebra. You can do this in C programming or any kind of language programming. Okay, this is an example. I print out, I want to scan my dimension. So n in this case is my dimension, meaning that how many rows and how many columns. Okay, so in this case, this is a square matrix, square entries. Why square? Because you can see that the dimension is the same, n by n, okay, because it stopped at n. I start from 1 until n, j start from 1 until n. Okay, when you see something like this, you can see if I equals to j, so meaning that I equals to j, when I equals to, so this is like a composite of what? Of conditional statement. Conditional statement is the if else and also the loop operation. Okay, and then if I equals to j, meaning that if I let's say 1 equals to 1, it will print out 1. If 2 equals to 2, it will print out 1. 3 equals to 3, it will print out 1. Otherwise, it will print out 0. So by looking at this statement right here, what kind of matrix is this? What kind of metric do you think? 1 equals to 1, the output is 1. 2 equals to 2, the entries, I'm talking about the entries. 1 equals to 1, means that row equals to column. The index for row and column is the same. the entries is 1, and then the next one 2 equals to 2. When the row and column is the same, the output is 1, and then the same thing until n by n, and then everywhere else, otherwise it will be 0. All right. Now I don't know if you understand. Do you understand what I'm talking about? Or you have no idea what I'm talking about? Or maybe you understand. Yeah.
So doctor mean that if it's the same number, you'll get 1, and if it's different from one column and the second column, you'll get 0.
Yes. So what does it mean in terms of matrix? Can you just imagine in your head that when the row and matrix, when the row and column is equal, the entries is 1. Otherwise, it will be 0. What kind of matrix is that? Reduce echelon form. One and 0. It's not that complicated actually. This is your basic in matrix, linear algebra. When row and column, the entries of row and column is the same, everywhere else is 0. Yes, identity matrix. Everywhere else is 0. The only thing that is the entries that is 1 is on the when I equals to j, meaning that when the column is equals to the rows. So which is what? Which is on the diagonal entries. So it is identity matrix. You don't be afraid to answer. If it's false, then we can make it correct. So that's how why we learn, because we want to correct what our understanding. Okay, so this is an example of writing the entries for identity matrix in n by n size, matrix size. So I start from 1 and so on. Okay, does it has to start from 1? My question is, does it has start from 1? I'm not talking about the printf, I'm talking about the index right here. So the index is the show that which position in the matrices or in the table and so on. It doesn't have to start at 1. You can start at 0. And if you start at 1, you need to be careful about the 0 index. Because why? Because for array, the index start from 0. Just remember that for arrays, index start from 0. Okay. Let's look at this one. Use nested loop to produce this table. Okay, so my entries, just use this one, this table. Okay, you can see that when my first row is 1, everything is 0. Everything is 0. And then after for the next row, x increased by 0.1, y increased by 0.1, but z is increased by 0.01. Okay, now let's see the next one. The third row, x increased by, you can see that 0 and 1, 0 0.1, 0 0.2. So the difference between these two is just 0 0.1. And this one is 0 0.1 also. But this one is different. So from this table, you can see that what's the value of increment for X? What's the value?
0.1.
Yes, 0 0.1, increased by 0 0.1 throughout. How about Y?
0.1 also.
All right. And then how about Z? How about Z? Z is quite different. 1, 4, 9. That looks like a square or something. Because we have 1 square 1 is 1. 1 to the power of 2 to the power of 1, 2 to the power of 2 is 4. This one is 3 times 3. Okay. So what's the relationship for how much is Z is increased?
It increased by the odd number, like 0.01 and then 0.03 and then 0.05. I don't know how to say.
Okay. Any other opinion? Because from this one, you need to know the formula for Z. You know X is increased by 1, meaning that you can do the X equals to X plus 0 0.1. And Y, you can use Y equals to Y plus 0 0.1. But if you want to put the entries for Z, now what's the formula for Z? Okay. Identity matrix. Okay, anybody want to try? This is elementary mathematics operation. You guys are university student. Okay, nobody has any idea the formula for Z? Now minus 1 over 10 squared. What's the value of num? Because you need to remember Z is changing iteratively. So meaning that the next step it will change. The next step it will change. So that's why I ask you, what's the specific value for num? Okay. Tak ada ni, no ideas? No ideas at all, Zamri? All right, so I have class after this, 5 minutes more and then we'll stop. Okay. I don't want to go on because I want you to answer this question. Okay, so 0.01, that's like what? If you say it increased by odd numbers, this one is even numbers, 0.04, that's even.
No, I mean it increased by like the first one is increased by 0.01, that's odd number, and then it increased by 0.03, which is also an odd number, then it increased by 0.05, which is
Okay,
also
so
odd number.
Okay, so this is like a series, you mean. For example, this one is 0.01 and then 0.03 and then
Yes,
0.05 and then the next one you expect it to be
0.07.
7. Okay, that's a good try. That's one answer. Is there any other answer? So meaning that the loop is changing by 0. Like an odd number. So you need to create another formula for that increment. So you have 2 increment, meaning that the increment by 0.01, 0.03, 0.05, that's one increment. And then the z is the changing of z in terms of that increment. Okay, so 2 kinds. Okay, now let me give you an idea. 0.01, if you see that, let's look at the first one, z is 0. Let's see this one. Is there any, can you relate the relationship between z in terms of x and y? Try to relate z in terms of x and y, the value of x and y.
X multiplied by y.
Yeah, which one is easier? The one that is by that odd decimal or x multiplied by y?
X multiplied by y is easier.
Yes. So that's so I told you I think in the early days of our lecture that if you have any kind of easier method, choose that easier method. Don't go for a really complicated one. So your first option is okay, no problem, because you can see that it is increased by increased odd decimals, but you can see that the easier choice is 0.1 times 0.1 becomes 0.01. 0.2 times 0.2 becomes 0.04 and so on. So that one is easy. So remember that when you do something like this, when you see some kind of entries like this, in most cases, it's not like a formula or something like that. Maybe you have to key in some data and so on, and that data doesn't have any formula. For example, if you want to analyze and you want to find an equation of some data, it's not that simple. You just key in the data. But in this case, this is easier because you can see that there's a formula for that. Okay, so the thing is right here, think about the formula first, and then think about how to use the nested loop to produce this one. Why? Because I'm talking about when you do the statement for output. The statement for output, which is the printf, x equals to x plus 0.1. So for y, x equals to x plus, as y equals to, maybe you can say y equals to x. That's also easy, an easy statement. And then z is just x times y. It's hard for me to write on this because I'm using Google Slide. There's no way that I can write what I'm trying to say in this Google Slide, which is not good. Okay, next time I'm going to show you. Next time I'm going to show you how to execute this table. by using the nested loop. All right, so I think that's it for now. I haven't